Okay, we're going to be looking at work prototype 1, constant force parallel to displacement. I'll remind you that in order to get the best effect out of these worked problems, whenever I ask a question or ask you to do a calculation, try to answer the question or do the calculation before it actually shows up on the screen. What we have here is a force applied to a block. It's simply moving a distance d from the initial x position to the final x position. And I show my xy axis. The system in this case is simply the block, and we have no friction. What is the definition of work? Well, work, the external work done on the block, since the block is the system, anything outside the system is the environment and is external, will simply be the integral from the initial position to the final position, the applied force dotted to the displacement or differential displacement. And this is a dot product. This is not a multiplication. Remember the definition of a dot product. What is the differential displacement vector in terms of unit vectors? Well, remember that we're going in the x direction. So if I move a little bit, then it must be a little bit in the x direction, a differential amount. So that's dx. And what vector, unit vector, belongs in the dx direction? Well, that's this di or I hat right here. So dr vector is dx I hat. Okay, what is the applied force in unit vector notation? Well, we write it here as a vector. What is it in terms of the unit vector? Well, the applied force is simply the force, and that should be applied, times the unit vector I hat, because it's in the positive x direction. What is the work done? Well, we want to calculate the work. Well, the external work is just simply this integral from the initial position to the final position, which is the magnitude of applied I hat unit vector dot product in dx in the I hat direction. And we can write that in terms of the initial position to the final position, simply dx, pulling out the constant applied force from inside the integral. And then we have the dot product of the unit vector I dot I. And of course that is 1. And then we can go ahead and finish the calculation and do the integration, which will be, of course, the applied force magnitude times the final position minus the initial position, which in this case is just simply force applied by the distance. And there's your very basic definition of work as force times distance.